Hey everybody, I'm back. This week we're going to talk about sanitary facilities and equipment. Basically, how you design your kitchen so that it meets the guidelines of your local health authority, and also so you can guarantee that food is safe. And this is an important one because there are lots of things that we don't necessarily think about in the design of a facility that are actually very critically important. If you're not aware of them, it's easy to overlook them. So I'm just going to give you some quick overview of this. Okay, so the first thing that we have to think about when we're designing a facility is that we want to think about the layout. Where is equipment going to be oriented? And there are lots of things that we have to think about when we're doing this. You want to think about workflow. So if you have certain um, pieces of machinery or workstations, do they need to be close to each other? It makes sense for someone doing vegetable prep, say for instance, to be near the vegetable storage area. So when we are designing a facility, one of the things we want to think about is workflow. Just where are people going to be walking and moving? And this in and of itself can go a long way to making the facility sanitary. If the areas that are likely to become contaminated are isolated and away from other areas. Other things we want to think about is contamination. One really basic rule is you can't have exposed pipes in a storage room because they tend to develop condensation, which is water will form on them. It'll drip on your dry goods. So that's just one basic consideration when it comes to contamination. Is like we want to design a facility to minimize the opportunity for contamination to occur. Accessibility to equipment. This just makes good sense that when we design a facility, we need to design it such that we can get to and easily reach the equipment that we're using in a safe manner. So one of the basic guideline is you come up with a design for your facility, how it's going to be laid out, and then you review it. And the important things we want to think about are that it meets regulatory requirements. So one of the things I always recommend is you can go to the local health authority if you're designing a new kitchen, and after you get your design, go to them and say, hey, this is what I'm going to do, and have the plans for them, and they are usually very happy to help you to point out if something's wrong, because it becomes really expensive if you build a kitchen and you get told, oh, well, this drain in the floor is 12 inches too far away, and it's a $10,000 renovation to change that. It's much easier to address that in the design phase where it costs you nothing to erase it and move it over. So you want to do a plan review. It'll make the flow of food safer and it'll save you time and money. So we'll talk a little bit about the things we use to build a kitchen. And let's talk about flooring first. An exciting topic. Flooring in a kitchen, the things that are really you want to consider is its porosity. And by porosity, does it absorb liquid? So what you want is a non-porous surface so that water or liquid can't be absorbed into the flooring and then also become a harborage space for microorganisms. So what we commonly use are red clay tiles. So if you look at the picture on the right, you can see the red clay tile flooring. And this is a very common type in a kitchen. It's non-porous, it's hard, it's difficult to damage. It's pretty much ideal for a kitchen. It's easy to clean. Another important consideration for flooring in a kitchen is what's called coving. And if you look where I'm pointing, you will see that the tile on the wall curves into the tile on the floor. So there is no sharp 90-degree corner there. There's actually a gentle curve. And this curve is really important. It serves two functions. One, it makes it easier to clean because you can get a mop or a broom all the way up to the edge, whereas if you have a sharp 90-degree corner, it can be difficult to clean in the point of the corner. It creates a space for dirt and things to harbor. The other thing that can harbor in that area that the coving presents is it prevents bugs from having a place to harbor. So if you have a wall like in your house where you have the floor trim meets the wall trim, there's actually space in there where roaches or things could get underneath. With this solid curved construction, which is called a cove, that I'm pointing to in the picture, there's nowhere for pests to harbor. So important consideration in a kitchen is to have coved flooring. Now, the different types of flooring we want. Really, what we want is non-porous resilient flooring. Resilient in that it's tough. So, like again, the red clay tiles are ideal. In other parts of the facility, we can have other types of flooring. So you can have other hard surface flooring like wood or things like that. And those are best in service areas, like behind the bar or something. And you can even have carpeting. But you probably want to limit your use of carpeting in a restaurant to, at the very most, the dining room, the guest areas. You definitely don't want it in any of the service areas in the back. And even in the dining areas, it's a trade-off. It's quieter, it's easier to walk on, and it looks nice, but it's also more difficult to keep clean and keep sanitary. So just like there are best materials for the floor, there are best materials for the walls and ceilings. And what's really important is that they are smooth. So again, you can't have a textured surface because again, you don't want anywhere that dirt can stick and hide. It needs to be non-absorbent, so it can't absorb moisture and lead to problems potentially with bacteria. And it has to be durable. It has to be tough because kitchen is a rough environment. Everything gets beat to death regularly in there. And once it's, like if you have a wall and you crack it, well, now that crack becomes a space for dirt and things to hide. So you need a very durable surface in a kitchen. So for the walls, the ideal surfaces, the ones that we prefer, are either stainless steel. So if you go in a professional kitchen, you'll see stainless steel sheeting up on the wall. That's great. It's easy to clean. It's really durable. Or ceramic tile. Ceramic tile, again, very easy to clean. You can wipe it down. You can get it wet. These are great choices. For ceilings, we have a little more flexibility because it's harder for things to get up there. So you can have tile, you can have drywall, you can have concrete or plaster. But again, what's important, it needs to be smooth, non-absorbent, and durable. Pardon me, I dropped my notes. Dry storage. We design dry storage, and again, there are certain guidelines we need to meet. So generally, it needs to be easy to clean. It needs to allow for good air circulation, and it needs to have shelving that is made out of corrosion-resistant metal or food-grade plastic. So you can't have shelving that rusts easily. You can't have shelving that will react with the food. And if you have plastic, it has to be food-grade plastic, which is tough. And when I say it's tough, I mean it's very durable. And as far as easy to clean, you need a solid, non-absorbent floor. Like here in the picture, we have concrete. And if you'll notice, the shelves have to be at least 6 inches off the ground. You can't store anything on the ground, and you have to have 6 inches of space between the bottom shelf and the floor, and this makes it easier to clean, so you can get a broom or a mop under there, and again, it makes it more difficult for rodents and things to have a place to hide. Other things about dry storage that are important. It needs to have appropriate amounts of light so that you can find things in there, but also you don't want it to have direct sunlight. It's a bad idea to have a window in your dry storage area. The UV light from sun will actually damage the packages. It'll make the food degrade faster, it'll break down, it'll go bad faster. So dry storage should be dark, except when you're in there looking for things. So you don't want a window in there. If you have window in there, it should be frosted or have shades. You should not have pipes in dry storage because your problem is either condensation, which I've mentioned earlier about moisture forming on the pipe and then it could drip down onto the food in dry storage, or you could have a leaky pipe. So if you have a a pipe that's coming from a plumbing that's maybe upstairs or in the attic or something. That could be a sewage line, and so really problematic. So you don't want pipes in dry storage. Um, we want to make it difficult for insects to get in. So we want to seal any cracks in the walls or anywhere else in the ceiling. You want to seal that with plaster or whatever the appropriate material is. Your doors have to be closing. They have to have a mechanism or a door pull on them that shuts the door automatically. Again, this is to make it more difficult for bugs to get in there. And you have to have if you have a screen, then it has to have 16 mesh to the inch, which means the what do you call it? The little wires in it have to the cross hatching. You have to have 16 of those in an inch. So if we have this, the cross hatching wires in a screen, we need 16 of these per inch, each of these little things. And that's a terrible attempt at drawing a screen. You'll have to forgive me. I'm trying to get better with this tool for drawing on the slides. Okay. So kitchens have to have hand washing stations. And so that the employees can wash their hands. And there are certain things that are required by law that you have to have in order to, meet sanitary guidelines. So things you have to have hot and cold running water. So we have to have hot and cold running water. Even in remote hand washing, like if you're doing a festival or something and you have a hand washing station set up outside somewhere, you still have to have running water. You have to have soap. If you have a restaurant and you do not have soap in the bathroom, it's a critical health violation, and the health inspector will get you. You have to have a means to dry your hands. So a disposable paper towel is fine. That is probably the preferred way to do it, is a disposable paper towel. So like right here in the temporary outdoor one, that's actually a towel dispenser up there. You have to have a waste container. So here's your waste container or your waste container. And you are also required by law to have the sign that says employees must wash hands before returning to work. This is actually a requirement of the health department. It's not a suggestion. You have to have this sign. So one thing you can look for in all these pictures that I'm showing you, that I put together for this slide, if you look carefully, you can find me in every picture somewhere. Okay, your restrooms, also kind of overseen by the health department the way it has to be designed. So the number of sinks, toilets, and stalls and urinals is set by code. So there's a formula of if you have X number of seats, you have to have this many urinals, or you have to have this many toilet stalls. That's determined by the building code. It is best to have a separate bathroom for your employees and a separate bathroom for your guests, if that can be accommodated. You have to have somewhere to wash your hands. It has to be convenient and sanitary. So it has to be convenient to the diners, and you have to maintain it. That's required by law. It has to be sanitary, and we know what sanitary means. You have to have self-closing doors. It has to be adequately stocked. So again, a bathroom that doesn't have soap in it or doesn't have hand towels, that is not in compliance and would be a critical health violation. And a closing waste container. So a waste container with a lid is preferred. Let's see. Other things we have to think about when designing a facility, the sinks. There are 3 types of sinks that we have to think about. We have hand washing sinks. Okay, so these are the ones that I've talked about previously. These are required by law to have signage, to have way to dry the hands. They're required to have soap. You have food prep sinks. So these are sinks in the kitchen, and there are requirements on how they have to be set up. And you should not wash your hands in a food prep sink, and you should not prep food in a hand washing sink. So you do not, use that other sink for what it's not intended. You can't throw the frozen chicken in the hand washing sink to thaw it. That's not allowed. That's a health code violation. Same thing, you should not be washing your hands where you prep your food. And the third type of sink is a service sink, or think of, this is a mop sink. And so again, you don't use that for food prep. You don't use that for washing your hands. Let's see. If we have dressing rooms or lockers, the important thing is they shouldn't be in areas where we store food or utensils. General guidelines for your premise. Free of litter. So if you have a parking lot and you have a lot of paper waste and cans and bottles in the parking lot, the health department will look at that and say, that's a place where you're providing food and shelter for rodents and roaches. So you got to clean that up. Ideally, your facility the ground should be graded so that water runs away from the building. Let's see, you should not allow patrons or guests to come through the food prep areas. And no one should be allowed to sleep on premise. Just some good guidelines there for good health. So now we'll talk about kitchen equipment and what it needs to be like. Kitchen equipment is amazingly tough stuff. It is designed to, I don't want to say be abused, but be used in a really intense manner. And one of the ways, and as such, it also tends to be expensive. For instance, you can go to Walmart and buy a blender and spend $40 and get a blender, but that blender is going to have plastic gears and is going to, you're going to be able to make a dozen or so margaritas in it before it burns out. But a bar blender, like you use in a restaurant, will be $700. It'll be designed with metal gears that can be replaced if it ever wears out, and that blender will run for years, if not decades. I used to work at a resort in Phoenix, Arizona that was built in 1927 and was in the kitchen one day looking at the steamer, which had the serial plate on it, and it had the date of manufacture as 1927. This was in 1997, so this steamer had been in continuous use, hard, in an industrial kitchen for 70 years. That's just the way that kitchen equipment is made. It's made to be incredibly durable and such that it can be repaired. So the general guidelines for equipment is it needs to be safe to operate, so that's both sanitary and safe, and so that someone would be harmed by the operation of the equipment. It's designed to be durable, as I just previously mentioned. It's designed to be corrosion resistant, so it's made out of something like stainless steel or some sort of other metal that will not react. Because a lot of the things we work with in a kitchen are acidic, like lemon juice and things like that. So if you have a metal piece of equipment that is reactive, that means it's going to rust, which means the surface is going to become uneven, it's going to become pitted, and again, that's an area that's difficult, if not impossible, to clean, and it'll wear out. So kitchen equipment is not designed to be corrosion resistant. All the surfaces have to be non-absorbent. So again, nowhere that can soak in moisture and hold it. So you can't have, a soft, spongy gasket in there. It has to be a gasket that is not absorbent. And other guidelines for equipment is if it's mounted to the floor, it has to be on legs that are at least 6 inches tall, or it has to be sealed to the ground. So either it has to be on legs that are 6 inches tall, or it has to be sealed to the ground so that there is no gap. And when we talk about sealed, I'm talking about with caulk and anything, so nothing, no roaches, nothing can get under there. If it's on a tabletop, it has to be on 4-inch legs or sealed to the tabletop. When buying kitchen equipment, what you want to look for there's some guidelines you can use to guarantee that you're getting something that's made to work in a professional kitchen. So you want to look for one of these labels here. So we have the UL label, which is Underwriters Laboratory, or the NSF, which is the National Sanitation Foundation. And these certify equipment as meeting the standards for a professional kitchen. So the general standards are they are able to withstand repeated cleanings. So everything in the kitchen must be sturdy, has to be non-reactive, and it has to be easy to clean. And it has to be able to hold up to the cleaning. You're not going to wear the surface off. You're not going to wear the coatings off. So it has to be smooth. Again, you can't have a textured surface that could hide things. And it has to be tough so that it doesn't chip or pit or scratch or score or get distorted. So these are the general guidelines for kitchen equipment. Talk about dishwashing machines now. And I'm going to run through these pretty quick. Important thing to remember about dishwashers in kitchens is there are a lot of different types. And things about dishwashing machines, some of them use chemical sanitizers. So you add a chemical, something like bleach or quaternary ammonium, to the machine, and it dispenses a little bit of it after the rinse to sanitize the dishes that go through. Or you can have some equipments that are hot water sanitizing, which means that the temperature of the water after the rinse, they'll spray hot water on it that is sufficiently hot enough to kill anything. You have to know what type of equipment you use, because with the chemical sanitizing equipment, if you use the very, very hot water on it, it actually it'll evaporate the chemicals faster than they get a chance to sanitize the equipment. So using the right type of sanitizing with the right type of equipment is important. General guidelines for dishwashing equipment is to design it so that the pipe runs, where you're installing it, are as short as possible, because those pipes, again, provide the opportunity for condensation. You need at least 6 inches off the floor, again, to be able to clean and provide no harborage. The equipment has to be designed so that it's sturdy. You have to have the information on it about how to operate the machine, where the chemicals go, and what type of chemicals to use. And it's required to have a thermometer that is accurate to within 2 degrees. Because again, the chemicals that are used, the soap, the sanitizer, or the hot water sanitizing, all operate within narrow temperature ranges. So you have to have a thermometer. So here's the first type of dishwasher I want to talk about. This is a single tank stationary type with doors. So by stationary, it means that the dishes stay put in the middle when you go in. So this type of machinery, I'll describe some of the parts. So we have a door here and another one on the other side where the dishes go in. Here the dishes are on a tray, and this tray will be pushed into the machine. You get in here and you pull this handle right here. So there's a handle right here. You pull this handle down, shuts the doors. The dishes are inside and they're washed. Here's the control panel for it is down here. You can't really see it up here, but on the wall, this is where the soap is mounted to it. And what's going to happen is the dishes go into the tank in here, and when it goes through a wash cycle, goes through a rinse cycle. The rinse water is then held down here in this tank. And when the next batch of dishes go in, they are actually washed with the rinse water from the previous batch. So this rinse water down here becomes the wash water for the next batch. So it's washed in the water that's already been used once. Then it's rinsed with clean water, and that clean water is saved for the next batch. So these commercial dishwashing machines are very efficient, much more than your home dishwasher, because they're using the water twice. So the rinse water becomes the wash water for the next batch. So this is a single tank because it has one tank down here, stationary type, so the dishes go in the middle and sit, with doors. Right here, these doors slide down and close this off. So here we have a conveyor. Oh, let's see, how do I clear all my markings off. So here's a conveyor type of dishwasher. This is, in this one, you put the dishes in on the end. They go on the same types of trays, so the dishes go in right here through this door. These doors ordinarily are down. These doors right here are normally down. They're open so that the machine can be cleaned right now. But the trays with the dirty dishes go through here. And this is a conveyor belt. So rather than the dishes staying put like in the stationary machine, the dishes actually roll through on a conveyor belt and come out here. Here is the chemicals, right here and here. If you'll see, again, it has tanks underneath for holding the rinse water for washing in the next batch. And this machine can handle more dishes than the stationary type. So this is for a larger operation. Here we have what is called a carousel conveyor, which means that the conveyor belt on this one, if you'll notice, is circular. So you load dishes on it, they go around, and they eventually enter the machine way over here. They come out and they're still in the conveyor belt. So if you didn't remove the dishes, they would just go in for another wash. So this is for a very large operation where essentially you're going to have dishwashing going for extended periods, where you have people continually feeding dirty dishes onto the conveyor and other people continuously removing clean dishes. The flight type, I'm sorry, this is a bad screen grab out of a video, but essentially here you just set the plates in these racks. So instead of using trays or using the separate racks, your dishes just go onto this type of layout and feed through the machine and come out the other side. And there are other types. There's what's called a batch type dump and a circulating door. There are lots of different types of dishwashers. So I just wanted to hit those real quick. Oh, sorry, gave you these guidelines. Just again, short pipe run, 6 inches on the floor, sturdy. You have to have the information about the chemicals and how to use it, and you have to have an accurate thermometer. Other pieces of equipment. Guidelines are kind of the same. It has to be sturdy. It has to be easy to clean. Sometimes we have pieces of equipment that are called clean-in-place equipment. And a clean-in-place equipment is something like the ice cream machine at McDonald's. Why is the ice cream machine at McDonald's always broken? It's not really broken. They just don't want to clean it. It's kind of a pain in the butt to clean. And it's a clean-in-place piece of equipment, meaning you can't take it apart and put it in a sink. So it has to be designed such that you can run chemicals through it or soap and clean it in place inside and out. We have things like blast chillers and cook chill equipment. And these are pieces of equipment that are designed to heat food and cool food to a safe temperature all in one process. And then with cutting boards, a nice rule of thumb is whenever possible, is that you should color code them. So I got cut off there. Important things about cutting boards are probably just to, if ever possible, color code them, such as red for raw meat, blue for seafood, brown for cooked meat, yellow for poultry, green for vegetables. That will help prevent cross-contamination. So now we'll talk about refrigerators and freezers, and there are important guidelines here for refrigerators and freezers. And again, if you look really carefully, you can find me in almost all these pictures. So here, what you're looking at is a picture of a walk-in refrigerator. We can also have reach-ins, which are portable ones that are on wheels. If you have a portable one, again, on wheels or legs, it has to be 4 inches off the ground so it's easy to clean under. They have to be constructed out of stainless steel or aluminum so it's durable and easy to clean and non-absorptive. They have to be designed such that the doors shut themselves. So if you look here, this door has a mechanism that shuts the door. And that's required. And your refrigerators and walk-ins have to have a drain in them. So all of them, if you look at them, you will notice that there's a drain in the bottom. Even your walk-in coolers will have a drain in the bottom. And so you'll have a little drain like this. And it's a 4 drain, makes it easier to clean because you can mop in there. But just as a management thing, if you ever go in a walk-in and it smells terrible, like it smells like sewage, something you may want to do is to get a glass of water and pour in the floor drain. Because what happens is the floor drain goes down and there's an elbow under the ground. And that elbow it's just like the one under your sink, and it's full of water. So this is all water in here. And the reason we have elbows like that is this pipe goes to the sewer. So this pipe that's running off the side right here is full of sewer gas. So it smells like the sewer. And what the water does is it prevents the gas from coming up into your facility. So if this elbow down here ever dries out, if that water evaporates, your sewer gas can come into your facility and it'll make your walk-ins stink like death. So a cure to that is to just pour a glass of water down the drain and it'll fill up this elbow. That's why we have elbows under the sink, is it's just to prevent our house from smelling like sewer gas, because all of our houses are connected to the sewer. And this is a particular problem in walk-ins and reach-in coolers, because refrigeration has 2 purposes. Refrigeration makes things colder, but it also removes moisture from the air. So it actually dries these things out pretty quick. So just, again, kind of as an aside, if you're ever in a cooler and it smells like death, pour a little water down the floor drain. That will probably get rid of the problem for you. So other rules about walk-ins and refrigerators: they have to have floor sweeps, which are those little rubber gaskety things on the bottom of a door that provide a seal. And again, it keeps bugs out from getting in there. It keeps bugs out, makes it easier to clean. They have to have forced air fans to circulate air in there to keep them cold. And they have to be sealed to the floor or wall. And wall, if you have a walk-in. Reach-ins, legs of up to 6 inches, or you can have it sealed to like a brick base. Important things is make sure they're big enough to meet your requirements. An overloaded refrigerator doesn't work. A refrigerator requires airflow. If you pack a refrigerator solid, you won't get airflow, and it's possible to have warm spots in a walk-in refrigerator or even a home refrigerator up to about 65 degrees if you don't have airflow. Let's see, so it meets your temperature requirements, has a built-in thermometer accurate within 3 degrees, and like I said, has enough storage space. And while I said you can have your refrigerators on legs, just like we're showing here, legs are fine, but casters, which are wheels, are preferred. So a rolling setup is preferred to one that is mounted to the floor. We'll talk about plumbing a little bit. This is an exciting topic. So let's talk about plumbing. First thing, our water supply. We have to have hot water. If you don't have hot water, that is a critical health violation. So you have to have hot water. You have to have potable water, and potable means that it is safe to drink. Now you can also use non-potable water, like from a source that's not approved. So if you have your own well that hasn't been inspected, but it's limited in what you can use it for. So you can use it for cooling, but not for cooling food. So like for air conditioning, you could use non-potable water. You can use it in your fire suppression system. You can use it for irrigation if you're growing either decorative or food plants. But for things that the public's going to use, the water has to be potable, has to be safe to drink. And this is water that comes from a tested source, like a well, from public water mains from a portable container, like a water tank, as long as it's been inspected, or a water truck. You can actually have water trucks brought in situations where you don't have access to clean water. You can get potable water brought in by truck. So some things to worry about, or the things you need to know. So first thing is a cross connection. A cross connection is a physical link through which contaminants can enter the potable water supply. So imagine you are in the prep sink area, where they keep, or not the prep sink area, the mop sink area where they keep the mop buckets at a restaurant. And you've got a faucet mounted on the wall, and then you've got, sitting on the ground, you got your mop bucket. And here's your mop bucket right here. Got the wheels on it. And over here, we've got our faucet coming out of the wall. Okay, so this mop bucket has been used. It's been used to, some kid had an accident in the dining room, and so it's been used to mop something up, and there's dirty mop water in here. And often when we go to fill these things in the room, there will be a hose attached to this. So as long as the hose isn't touching the bucket, that's fine. That would be fine. But what ends up that's not what ends up happening. Is someone has been in there and they're in a hurry. They've filled up another mop bucket or something, and they throw the hose down, and the hose is laying here in the mop bucket. Now, so you wonder, well, what could possibly happen? Well, what will happen is when you turn off the faucet up here, it can create a vacuum. Just like siphoning something, it creates a vacuum. And when you shut it off, it will actually draw water up the hose. So the water moves up the hose and into the faucet. And this faucet is connected to all the sinks in your facility. So now you've just sucked dirty mop water up into all the sinks that are going to be used for hand washing, for drinking, for cleaning food, for cooking. You've now contaminated it with whatever's in that dirty mop water. So that's a cross-contamination. A cross-connection. We absolutely do not ever want to have that situation. So this movement of liquid or contaminants into the potable water supply, this movement up the pipe here, that's called backflow, and that's a serious problem. So there's some things that we do to prevent backflow. One thing is, if you look at a faucet that we have in kitchens, like the one over on the left, this little device right here, it looks kind of like a bell on the top of the faucet. This is actually designed, it's got a diaphragm in there, and if there is a vacuum, like if this faucet had a hose attached to it, and the hose got thrown in something and there's a vacuum, this right here, this diaphragm opens up and sucks air in and breaks the vacuum so that it cannot siphon water back into the facility. So vacuum breakers are something you should have. And the other thing that you want to have is what's called an air gap. And so that's the space between the faucet and the water, the contaminated water. So if we have a sink, for instance, give me a second, get rid of all this stuff. If we have a sink, that we use for vegetable prep, here's our sink. Okay. And we have a faucet. Okay. This gap right here, that is the air gap that separates water, because the water level in the sink could go, like right to the top. Okay, so there is no way that if this water down here is contaminated, it's not, it can't jump up into the faucet. It's not going to happen. Now, it's possible that you can have a design where, let's say for whatever reason, this faucet up here extends down. Well, now it's possible right here that the water could hit the level of the faucet. So this is an air gap. Here's the illustration of an air gap right here over on the side. That air gap prevents water from being sucked up into a faucet. And forgive my terrible drawing skills. It's really hard to do this with a mouse in PowerPoint. So on the exhaust or the sewage side of the sink, so we talked about water coming in. Now we're going to talk about water going out. One of the things we need to have is a grease trap, and it helps prevent what's called FOG condensation in pipes. And this is not fog, this is fat, oil, or grease. So if you think about butter, you can melt butter and it's nice and liquid. But what happens to it when it gets cooled? Well, it turns solid. So your pipes underground are cooler than the air outside. So the grease that gets run down the sink, or the little bit, when we're cleaning or whatever that goes down there, has the potential to solidify, and it will solidify in your pipes, and then you get a sewage backup. And if you have a sewage backup in your facility, you have to shut down until it's corrected. So what we have are what are called grease traps, which help filter the fats, oils, and grease out of our exhaust water as it leaves the facility. So let's see if I can. So this is a pipe that doesn't have a grease trap on it. And so this nasty buildup here, this is grease. And you can see this pipe is almost completely blocked up. And won't take much more until nothing's going to flow through that pipe. And that's nasty. Okay, that's just nasty. So things you want to know, they have to be installed by a professional. They do require a little bit of maintenance. You have to empty them because the grease is filtered out of your water and it accumulates in your grease trap. And so periodically you have to have someone come out and clean your grease trap for you. There are some small internal grease traps that maybe you have your kitchen staff clean, but for the most part these are large underground containers. They'll be out in your parking lot somewhere. So they have to be maintained regularly. They're required by law because if you don't have one, you are clogging up the municipal pipes, and you can cause a serious backflow, and you can destroy sewage treatment equipment if you're putting grease down the pipes. If you don't have one, you're subject to fines. You're subject to loss of revenue because you'll have to shut down while you're cleaning the pipes. But actually now you can actually make a little bit of money off your grease traps because the fat and oil and grease, you can actually have companies that will pay you to come out and clean them because they collect the fat and they use it to make biodiesel. So you can actually generate a small amount of revenue off of your grease traps now. So here is a grease trap, like an external one, like would be mounted out in your parking lot. And what happens is the water comes in through this pipe. Water has a little bit of grease in it, goes down the pipe right here, emerges. Now what do we know about fats and oil? Well, they float. So the fats and oil, they come up here on the top. All this yellow stuff is fat and oil. So that's fat and oil sitting on top of a layer of water because the water goes to the bottom. So the outlet for the pipe is down here. So it goes into the space. The fat floats to the top. The water goes to the bottom. The outlet is near the bottom, so the water enters the outlet, goes out into another chamber. Again, fat floats, water sinks, The exit is way down here. So what comes out of the other end is mostly water. There's very little fat because the fat collects in these chambers up here. And so from the top, from outside the parking lot or wherever you have your grease trap, what you have is you have a manhole or a lid out in the parking lot, these things right here, that can be opened so that this fat can be vacuumed out. And trust me, pay somebody to do it because there's nothing in the world that smells worse. That's the voice of experience. Just pay somebody to do it. It's money well spent. So this is a big external one like in the parking lot. This is an internal one. So let's say you have a facility and it hasn't always been a kitchen. It was built for some other purpose, and you can't have an external grease trap. You can actually have these internal ones, which is what this is right here, that mount under a sink. And the baffled area where the grease collects is this thing down here. So just when this fills up, you go out and you dump it into your grease pit or wherever you have to dispose of grease. But let me tell you, this thing down here smells terrible when you open it. So whatever you do, pay somebody you don't like to open that. Sewage. Now, if you get a clogged pipe, say you don't have a grease trap, and you get sewage backing up on the floor, you have to immediately close and correct the problem while you clean it. You can't operate a restaurant with poop on the floor. Not allowed. General rules, just things to think about. We need to have enough light in our facility to be safe. Now, light is rated, like how bright something is either given in foot candles. There's what's called a standard candle, and how bright is it from a foot away, or luxes, or lumens, or luminaires. There are lots of ways of describing this. What's important is that just make sure you meet whatever your health department requires, or your building codes. You want it so that your lighting is kind of, in the prep areas especially, is even, so that you don't have dark shadows where things maybe you can't see where they need to be cleaned or difficult to notice. You want to have shadow resistant bulbs or bulbs that are covered in the lights in your prep area. And let me just tell you that twice I have managed to shatter light bulbs with a mop in a kitchen and had glass rain down on my food prep. So a covered or shatter resistant bulb is a good investment. And you should also have shields for heat lamps. Heat lamps are just light bulbs that get super hot. But if you touch the glass surface of a heat lamp by accident, maybe with a cleaning rag or something, especially a cool wet rag, it will shatter the lamp. So you should have shields over the heat lamps because they are very prone to shattering. So here are the guidelines for how bright things need to be. So say food prep areas, 50-foot candles, just meaning relatively very bright. You need to be able to see everything that you're doing so that it's safe and so that you can clean. In other areas, restrooms, reach-in equipment, hand washing areas, 20-foot candles is sufficient. In dining rooms and dry storage area, it can be even less at 10-foot candles. So again, just make sure that you meet the guidelines of your area. The ventilation in our facilities is super important. It removes smoke, steam, grease, and heat. So the hood above your stove, it has to be operational. So it takes smoke and steam from cooking out. You want to take that steam out because if you don't, it'll condense on the surfaces, and then it can start dripping in things. That increases the risk of contamination. So you want good ventilation to get the steam out, to get the smoke out, because your guests don't want to breathe it. To remove, there's airborne grease. The ventilation removes that, and that's why you have to have your ventilation cleaned regularly, as the grease will accumulate in there. And it removes heat. So your hood removes the heat from your facility from cooking. One thing I'll warn you about, and again, this is the voice of bitter experience. If you're ever in a kitchen, and in the hood area in the kitchen, they will have these little pipes that come straight down like this. out of the ceiling inside the hood, and usually on the end they'll have little plastic caps. Kind of like, it's a little plastic cap right on the end. This is the fire suppression system. And in here is a wax cap that's designed to melt at a certain temperature. So if your hood stops working, the heat from cooking will build up and it will actually melt this. It'll set off your fire suppression system because it thinks that there's a fire in the kitchen because it's too hot. So if your hood stops working, stop cooking. Because if you don't, you're going to set the fire alarm off and you're going to set off the fire suppression system, and then you're going to have to clean up all the fire suppression chemicals. The ventilation reduces odors, so it smells better. Airborne dirt, mold, humidity, all the things that it takes it all out of your facility. And so where do we need a hood? Well, we need it in cooking areas. We need it around steam tables, and we need it in dishwashing areas. Those are where we're supposed to have hoods. So here's a picture of a hood. And so it's designed to make sure that nothing drips into the food. So one thing we've got right here, if you'll notice, is this is all tile, easy to clean. And here's the hood. So up here, gas goes through these strakes where it's then filtered and goes to the outside. So we've got smoke, steam, grease, everything up there. Now, one thing that you'll notice is about the design is that the piece on the bottom right here, where potentially oil could condense on these things or moisture could condense on these things, it runs down into this channel. And if you'll notice, this channel is at an angle. So we've got a large, up here to here, the difference is pretty substantial. So anything that drips in this, that condenses, goes in here and runs down this channel. And it runs all the way to down to this end, where there's a hole where it goes into this pan. This pan can be removed and cleaned. So this little bit of angle right here is designed if there is any condensation or dripping, so that it gathers here, so that you can throw it away. It's easy to clean, rather than having stuff drip off of here onto your food prep area. So it could drip off of here down onto what is a flat top. So you could actually have grease or moisture or dust dripping on your food. So having this angle in the equipment prevents that. If you have ventilation, you have a hood, you have to have replacement air. Those hoods suck a lot of air out of your facility. You actually have to make sure you get new clean air coming in to replace it. A well-designed air conditioning system accommodates this. But otherwise, what you're going to end up doing is you're going to end up sucking air out of the dining room. Doors will be sucked open. But when it's sucking those things open, it's also sucking in dirt and dust and contaminants and airborne insects into the kitchen area. So you have to design it so that you have sufficient replacement air for the air that's exhausted. And depending on where you are, your exhaust may have to be filtered. So some guidelines for garbage. Basic things here, reduce, reuse, recycle. So as much as possible, reduce the amount of waste you have. Select packaging that items have less packaging. Whenever possible, reuse equipment or thing or packaging as much as possible. One thing that's really common in kitchens is we get pickle buckets come in pickles or a lot of things come in 5-gallon buckets. Those buckets get reused on and on and on forever. And then wherever possible, recycle. So again, if you do have packaging, cardboard, aluminum, things like that can be recycled. Rules about garbage. We just want to make sure that we get rid of it as soon as possible. Having garbage around, it attracts pests. It's food for vermin. It's food for insects. It has potential to contaminate our food, our equipment, our utensils. And the areas where garbage is disposed of, wherever you keep the trash cans, you have to have an area to clean your trash cans that have hot and cold water. So you have to have probably in your loading dock, you have to have a facility somewhere where you can clean your garbage cans, and it has to have hot and cold water. That's required. And why do we want to do this? Because we don't want to attract pests. Animals are drawn to garbage. They see it as food. Some other things that we can do that are important. A garbage disposal in the drain. So again, food products can be ground up and run out through the sewer where they can be broken down. This is only really good for a limited amount of food product. A pulper or a grinder is a good alternative. This is an area where this is a machine you can put your garbage in. And what it does is it essentially removes the liquid. And if you think about the fact that water weighs 8 pounds per gallon, if you're able to run a lot of food material through there and remove the water can go down the sewer, no problem. The solid parts can be disposed of in a landfill or in the garbage much more efficiently. Last thing, wherever you store your garbage outside, where your dumpster is, the ground should be smooth and non-absorbent. So you shouldn't have a dumpster sitting on dirt. It should be on a concrete or an asphalt pad. Okay, so that is it for equipment. I hope you guys have a good week, and I'll talk to you again soon. Bye-bye.